In this video, I will illustrate how to create a data collection worksheet for a 2 to the 3 factorial with replicates in a spreadsheet. To begin with, we'll open a blank worksheet as shown on the screen. Next, we'll open the worksheet that contains Appendix B.2 and specifically Table B.2.3, which is for a 2 to the 3 factorial. We will copy the coded factor levels in columns C through E, go back to our blank worksheet and paste these in, and we will label these as coded factor levels. Since we're going to have replicates in our experiment, we'll copy the coded factor levels again and paste them down below so that we have 2 replicates of each condition. We'll type the run numbers in the first column. And now we'll create columns for the uncoded factor levels in E, F, and G. The first factor is the fly ash, and this is a discrete factor that has 2 levels, A and B. So we will use the if statement to translate between the coded levels -1 and +1 in column B and the actual levels A and B in column E. So I will type in the if statement So if B4 is equal to -1, we will assign fly ash to be A, otherwise B. And we will copy this column down to create our actual factor levels for fly ash. The second factor is the water to cement ratio. So I'll type that in column F. This is a numerical factor, and the coded factor levels is given by the coding formula. X2 is equal to the water cement ratio minus the midpoint 0.45 divided by half the range 0.1. We will want to solve this equation for the water cement ratio, which will then be equal to 0.45 plus 0.1 times x2. Now we will go back to our worksheet and enter this equation. Equals 0.45 plus 0.1 times, and the coded factor levels are in column C, and we will copy this down to the bottom of our worksheet and get the actual factor levels for water to cement ratio. The third factor is the setup time. So I will type that in column G. This is again a numerical factor. The actual or the coded factor levels of setup time are given by the coding and scaling formula, And if we solve this for setup time, we get 20 plus 10 times the coded factor levels x3. So we'll go back and enter this equation into our worksheet. Copy this down, and now we've got our actual factor levels in column E, F, and G. Now we'll want to create a random run order. So let me type that in column H. We will create this by starting with some random numbers over in column L, which I will create using the rand function. This creates a random number between 0 and 1, and I will drag this down to the bottom of my worksheet. Next, I will create the ranks of these random numbers in column K, and I will use the rank function to do that. So rank of the value in cell L4 with respect to the values in L4 through L19, and I will enter these column identifiers with a $sign to anchor them so that when I later copy them they won't shift. So L $4 colon L $19, and then I will place a 1 to indicate I want the ranks in ascending order. And here's the rank of the random number in cell L4, and then I will just copy this to the bottom. And next I will copy these run orders and just paste the values into column H. And now I can clear the random numbers in the remaining part of the worksheet. And now we have a completed worksheet. We can enter a column for recording our response. And according to this worksheet, the experiment in row 4 with fly ash type A, water cement ratio 0.35, and the setup time of 10 minutes would be run first. The second experiment would be the one in row 12 with fly ash type A, water cement ratio 0.35, and setup time 10, and so forth. The third one here, and we would complete all 16 experiments and record our responses over here.